So what we have here is the 2019 HIAT. This is paper 1, question 17. Now the focus of this question is obviously integration with trigonometry involved. Now there's two parts to this question. Part A wants us to expand and express this bracket in the form here, p plus q sine r x, where p, q and r are integers, and then hence find this integral. So again, that word hence that we've come across many times in the course, hence meaning use what you've just done. So let's start by looking at part A. So express this in that form. Well, I've got sine x minus cos x in a bracket. The bracket's squared. Let's multiply out the bracket. So if we multiply out the bracket, what I'll get is sine squared x minus 2 sine x cos x, then plus cos squared x. Now what I'm going to do is I'm going to group some terms together. I'm going to group the sine squared and the cos squared together. And I'll have sine squared x plus cos squared x. I'm then going to have minus 2 sine x cos x. Now, at this stage, doesn't look like what we have up here at all. However, this is where trig identities come into play. Sine squared plus cos squared, well, that equals 1. 2 sine x cos x, well, we should know that that is equal to sine 2x. So if I use these, what I can do is substitute them in and say that that's the equivalent of 1 minus sine 2x. So there you go, I've got it in this format here, where p happens to be 1, q happens to be negative 1, and r is equal to 2. So that's part A done. Part B says hence find the integral of that. So hence meaning use what you've just done. So what I'm going to do is take my integral and I'm going to rewrite it as the integral of 1 minus sine 2x dx. So what I can now do is just integrate this straight up term by term. So what that will give me is x plus a half cos 2x. Because remember, sine 2x becomes negative cos x, but sine 2x becomes negative cos x times 1 over the derivative of this, so times 1 over 2, so x plus a half cos 2x, and then the most important part, when we've got an indefinite integral, plus c. We have to include that plus c. We've no values to integrate it between. We've no conditions at that point to be able to calculate that constant of integration, but we still need to include it and show it's there. It's a vital part of being able to do this. This question, fairly quick, nice one to finish off. Nice ending to the paper. First part's worth 3 marks. Part 1's for expanding the brackets. Part 2 is using this part here, the double angle formula. And then part 3, interpreting the sine squared plus cos squared and getting a final answer. This second part here is worth 2 marks. So firstly, linking it to part A. So writing it as this. And then finding out your part B plus your C, second mark there. One point to note is that the mark scheme says linking it to part A. So if I had done this and I had it wrong, let's say I'd written down 1 plus sine 2x, I would lose the mark there. But in this part here, because of the hence, if I then use the 1 plus sine 2x that I'd got here, I could then still get full marks in this question by integrating that function correctly. Hence, remember, means use what you've just done. So if I use what I've just done, get the right answer for what I've used, despite it overall being the ultimate wrong answer, I could still get all the follow-through marks and get the final solution correct, so I can still get the majority of the marks in there. So if I got this wrong, like I say in written plus, I'd have lost this mark, but I could still potentially walk away with 4 if I'd done part B correct using what I got as the answer there. So it's little tweaks and little bits of vocabulary that we need to watch out for when we're doing questions like this. Go away, learn all your trig identities, make sure you know every single one of them off by heart so that you can just jump straight in when you've got a question like this, group relevant terms together and know exactly how you can rewrite it such that you can make an integration like this a heck of a lot easier.